let's talk single and multi-camera calibration. Now you'll see I have my board from before, now with the LiDAR stickers attached, but we're just going to be using the fiducial in the middle for this camera segment. Now, when taking data for camera calibration, you're going to have the same concerns as you do with photography in general. Keep all of your features in focus and keep them in frame. The primary things we're going to be calibrating for both single and multi-camera, are going to be the intrinsics, which is the focal length of the camera and the distortion pattern of the camera. When we're discussing focal length, the most important thing to capture is distance from the near features to the far features of your board. What this means in practice is that you're going to be introducing a lot of angles into your calibration procedure. In fact, the more angles, the better. However, you'll notice if I introduce too much angle, we can't see the fiducial anymore. So there's a realistic limit to how far you can bend your board, but try as much as you can. The second thing we're looking for is the feature coverage in frame, which will inform our distortion parameters. If I keep my board straight ahead and only move within the center of the image, my distortion is only going to be fit to the center of the image, where the most distortion in a camera is actually off to the sides. So what we want to do is move our board around the entire frame. And this will allow us to optimize the distortion correctly. Putting these two aspects together, you're going to have angles and movement across the entire field of view of your camera. This means that in the beginning, your camera calibration is probably going to have a lot of movement, too much, in fact, than what a normal operator would want. However, MetroCal has a motion filter built in, which means that you can actually cull data that isn't necessary. This is really helpful for rolling shutter cameras and patterns where you might have a lot of motion blur.